Even if someone is, above average in their intelligence score, that does not necessarily mean that they're above average in terms of IQ. It's just talking about kind of population averages. And I don't think that's something to hide from, right? We all know that intelligence is one piece of a life. And we also know, based on what I just told you guys, that there's no such thing as kind of biological determinism, right? No one's going to be extremely intelligent from their DNA. And so I think that's part of all of that is part of the communication. It's complicated. And we trust that our customers can kind of understand this nuance, understand some of this complexity, and we do our job in nicely presenting this information so people can understand all these considerations.
All right, guys, bang, bang. I've got Kian here. You're trying to do something that no one's ever done before, which is take this DNA information that everyone knows is possible. They've seen some of the competitors that are out there, but you're trying to give the information to the people, which I think is a very interesting detail because most people don't know that the companies that you've previously given your DNA to, they're withholding information from you. They are not telling you everything that they know about you. So in a weird way, these other companies know more about their customers than their customers know about themselves. Is that true?
I think there's multiple layers to this, right? One is a technological limitation that these old companies had. Another is an ideological limitation. So let's start with the technological one. When companies like 23andMe got started in 2006, the cost of sequencing the entirety of someone's DNA, all 6 billion letters that makes up someone's genome just means the entirety of someone's DNA, it was around $10 million per sample, $10 million per person. That's insane. That's obviously not economic. So instead what they did is they opted for a much cheaper technology called microarray technology. This technology looks at less than 0.1% of someone's DNA, right? Today, that cost has gone from $10 million per sample to look at less than 0.1% of DNA to around, $399 basically to read the entirety of someone's DNA, all 6 billion genomes. So the first thing that you should know is that Nucleus has far more data, right? We actually can analyze much more. And by analyzing much more, we can give people the entirety of basically the scientific frontier of insights into their genome, far more accurate assessments of their disease risk as well as their trait dispositions.
So the cost has come down significantly, which is a huge advantage.
Huge advantage for the company, yes.
Now, that's easy for people to understand economics.
Yes.
There's an ideological predisposition that they have, which basically means they believe things that maybe you and I don't believe.
Yes.
What do they believe and why are they maybe misplaced in those beliefs?
I think there's a bit of a conservatism when it comes to genetics. And I really believe that part of Nucleus's job is to empower people with information. There are studies done at the scientific frontier in the genetic architecture for things like intelligence, as an example. And these are studies, they're published in the most esteemed scientific journals. They're done by, some of the most esteemed private institutions in America and also worldwide. And they basically start exploring the genetic architecture of what some might say might be more controversial traits. And I think it's our job as a company, instead of sort of having this information gate-capped when it's really public in the public domain, it's in the hands of the people, is to provide people access to these sort of insights while also being still thoughtful. I think we can be focused on acceleration while also not, that doesn't necessarily mean that we have to be reckless, right? I think it's about empowering people with this knowledge, educating them today about what exists in the genomic frontier and then how it's going to evolve over time.
Now, as you go into the frontier, there are things that are very controversial with these legacy companies in terms of what potentially is possible. When you and I first met, I think I asked you some version of a question of, okay, great, like, why are you different in doing all of this? And you explained the cost and the ideological stuff, but you also started to talk about there may be genes that people historically have thought didn't exist. Maybe they do exist, and maybe we don't actually know for sure or not, but it's worth pursuing. Intelligence gene, gay gene, right? Many of these things that, again, are almost in some degree, there's certain scientists who say absolutely not. It's, heresy to even talk about it. And you if you believe it, you are just like some crackpot. And there's other scientists that say, well, actually, we should do the work and try to figure out, do these things exist or not? And so, like, how do you think about some of these more controversial genes and like the pursuit of doing science around them?
It's a good question. Genetics has evolved quite a bit over time, where the models have become basically more sophisticated. And what they found is for that more common, what they call complex diseases and traits, things like, let's say, breast cancer, type 2 diabetes on the diseases side, and on the trait side, things like intelligence or muscle strength, what they find is that they're complex in nature. What that means is that they're not driven by a single gene or a single variant. You can think of the genome as like a circuit. And basically, there's a complex interaction between many DNA differences in someone's genome that ultimately results in their disposition. If you think about like intelligence, the same genetic architecture is true for any complex trait, even like height, right? It's not a single gene. It's the interaction of many differences in someone's DNA that also leads to someone's expressed trait or even disease risk. So over time, basically, scientists have started saying, okay, how do we kind of understand this and explore this? And then I think part of our job is to bring this information, this entirety of the scientific frontier, in the hands of the people. Right? So people can start understanding and making sense of where the models today, which are admittedly more modest, but how will this evolve over time, right? And I think that's a key question that as the leader of the genomic industry at this point, we have to be very judicious and thoughtful about while still giving people access to that data.
How do you strike that balance? Do you give them 100% of all the information, or do you try to give them insights?
That's a really great question. So one thing to understand about genetics is that across different diseases and traits, there's basically a theoretical maximum that genetics can possibly predict. So intuitively, people already know this. Take something like height, for example. If you look at height, scientists basically estimate, actually before I even give you the number, you probably think, Pomp, okay, height, that seems pretty genetically driven, right? Two tall parents, tall kids, usually there's some deviation, but that's the thing. Something like extroversion, less so, right? Sometimes you have really kind of more, I would say extroverted parents, but the children are not. And again, I'm being a little bit qualitative right now. Scientists can actually map quantitative measurements of how much the basic variation in a disease or trait can be basically explained by genetics, the theoretical maximum, right? So there's always this tension. People say nature or nurture. It's not nature or nurture. It's always nature and nurture. So height, for example, scientists estimate that 80% of the variation in height can be attributed to genetics. Extroversions, let's say 30%, intelligence is say 50%. So that would mean that even if you built a perfect genetic model, right, still obviously 50% is not attributed to genetics, right? And that's not a bug, or that's not, that's just what it is, which makes perfect sense. It's obviously a function of both the two things. So I think part of our job in our communication is expressing kind of both where the models are today and also then what is kind of remaining or what's left. So trying to think about closing that kind of gap of where the models are today and where they can be tomorrow. And to that point, I think people need to understand that even if someone is above average in their intelligence score, that does not necessarily mean that they're above average in terms of IQ. Similarly, you can be below average and you can still actually be above average, right? Because there's still a lot of basically error in these models. It's just talking about kind of population averages. And I don't think that's something to hide from, right? We all know that intelligence is one piece of a life. And we also know, based on what I just told you guys, that there's no such thing as kind of biological determinism, right? No one's going to be extremely intelligent from their DNA. And so I think that's part of all of that is part of the communication. It's complicated. And we trust that our customers can kind of understand this nuance, understand some of this complexity. And we do our job in nicely presenting this information so people can understand all these considerations.
Now, when I think of a lot of the genetics work that has been done previously, it's about understanding. It's not about taking action, right? It's very much what am I predisposed to from a disease standpoint? Where did my family come from, right? Are the stories that my grandparents told me actually true, or is science saying something different? Is there some ability for me to begin to understand what I'm predisposed to from maybe it's intelligence or height or whatever? But when people get information, they want usually the information to take action. It's kind of great. I now understand X. What do I do with it? Yeah. And so you and I have are very fortunate to have a bunch of crazy, insane friends who come up with all kinds of, on one hand, smart ideas. On the other hand, could be potentially horrible ideas. And sometimes there's a very thin line between those two things. But as I've heard people talk about the advancements in genetics, I've heard people say, well, why don't we create a dating app where people's IQ or some sort of genetic disposition, so that if you're looking for something, you can go find those people to then create, babies and a life and a family, et cetera. Again, you can tell very quickly there is this thin line between what is positive impacts of something like that and what are the negative downsides of something like that. And so like, I'm sure you having, spent a ton of time on this every single day, have heard all kinds of ideas as to like, once we understand some of the genetic stuff, what do we do with it? And so where do you think the world is going to go? Is it simple things like dating apps, or are there much more profound use cases for some of this information?
So yeah, there's a lot of questions there. Let me unravel them a little bit. So on the disease side of the things, I think there's like 4 very obvious applications. The first is what I think consider kind of more extreme, but super actionable. So sometimes, unfortunately, you see athletes suddenly drop dead. It's tragic, but it happens. Also, my cousin suddenly died in her sleep, as an example, right? Sometimes that can be actually do something called long QT, which can be genetically linked. If you know you're disposed to long QT, right, you may have no symptoms until later on, but if you know genetically you are, you can take something called a beta blocker, which reduces your risk 10x, right? So that's a super actionable, super clear application of genetics. Then there's another bucket for the kind of complex diseases you've always heard of, right? Things like breast cancer, type 2 diabetes, familial hypercholesterolemia, high cholesterol, right? These are all conditions where a genetic test can save your life. Where if you know you're at greater risk for breast cancer, for example, you can get earlier, more aggressive screening to catch the cancer earlier. And obviously, once you catch the cancer earlier, you can actually get rid of the cancer far more effectively. Okay. Then there's a third bucket like Alzheimer's, for example, where there's no actually explicit cure today, right? If you're an E4 carrier, or based off our polygenic model, you're higher risk. But you already can start, I think, for me, I think it what I've heard from people who are disposed, it brought a certain beauty to their life, because they appreciate so much more their day-to-day and how kind of fragile it is. And moreover, they already begin participating in different sort of research studies to try to cure Alzheimer's, which I think is very powerful and informative. Then, of course, you mentioned dating apps. I think on the kind of inheritance side of things, there are still babies that are born with basically monogenic diseases. So basically both parents are carriers and they pass it on to their offspring. I think what's going to end up happening is you're going to have basically mass whole genome sequencing, and then every single couple in the United States should know if they are both a carrier for a disease, so they can use that information to, if they would like, it's obviously their liberty, it's their choice, to basically have a baby without a disease, right? So I think that's a huge, powerful application that's getting missed, where basically multiplication could potentially stop a baby being born with a very debilitating condition. On the dating app side of things, I think honestly people don't need genetics for that. I do think though on the what I described, where potentially what will happen is if 2 people are carriers and they both choose to opt in, right? If let's say you're on Tinder or something and both people are carriers for a condition and they both opt in, maybe potentially the algorithm does it such that those 2 people don't ever meet in the first place, right? And it'll be really rare. And obviously both is about individual liberty. It's about both parties opting in. To that point, what I'm saying right now, someone might be like, oh, that's horrible, et cetera, et cetera. To me, it's all about giving the power to the customer. The customer should choose whether they want to engage and opt into that or not, right? It's not the job for Tinder or for Nucleus to say, oh, you shouldn't or shouldn't do this. It's our job to basically empower you with the scientific frontier of information, scientific frontier of knowledge, and then use that knowledge of how you want to live healthier, happier, and potentially how you want to have a healthy family, which I think everyone has the right to, of course.
What about things like food, right? I've seen a bunch of people say, hey, maybe not so much just genetics, but let's take a bunch of tests, let's figure out your body, understand it, and then we're going to come up with a personalized diet, as an example. How much does genetics or anything like that play into some of the things that maybe are more practical for people on a day-to-day basis?
So sometimes your disease risk can be obviously directly shaped by what you eat. For example, if you have a high AMD risk, right? And AMD is a later onset condition, one that takes a lot of time. You should, blueberries, as an example, is found to actually decrease your risk. So there's various cases like that where diet matters a lot. It matters a lot. And eventually we're going to be able to quantify in Nucleus how much basically what you're eating, how it shapes your disease risk. In terms of exactly telling you what you should eat, those are some softer associations generally, strictly if you're talking about just the primary DNA sequence. But definitely, obviously, the entirety of someone's lifestyle interacts with their DNA information. And that's why if you look at Nucleus, we actually incorporate both someone's genetic data, their whole genome data specifically, with non-genetic data to come up with these overall estimates of people's disease risks.
And when I go and I use the kit, what is...
Which you have. You ordered it.
Yes, I did.
Amazing.
Not only did I order it, a lot of my friends ordered it. And then we all talked and we were like, do we want the information? Like we were a little scared, right? Because it's also a thing where I remember listening to Peter Attia, and I think that he did some sort of test
Yeah, he did.
With maybe Chris Hemsworth, if I remember
Yes,
correctly.
I think it was Alzheimer's, maybe even.
And so in this, and they were recording a show doing this. He was going and doing tons of different physical tests. He was like swimming in the Arctic Ocean, all kinds of crazy stuff. But cool, and people were paying attention. And in the filming of this, they figured out that he is predisposed to Alzheimer's.
Yeah.
And so Attia had to tell him, and it seems to have really kind of messed with him a little bit.
Yeah.
And so he said, hey, look, I'm going to take some time off. I need to figure this out. Are there things that I can do today to decrease the risk, et cetera?
Well, he recommended everyone should do it.
Correct.
He did, yeah.
But I think that, it's one of these weird things. Like if you take it to the extreme, right? If I tell you when and where you're going to die, do you want to know?
We can't tell you that. If we knew that, we would.
Well, you guys can't, but I just mean like if somebody could tell anybody, right, the day that they're going to die, how they're going to die,
it's the
when.
opposite, Pomp, because you give you information so that doesn't happen.
Correct.
Right. So it's the ultimate liberty. It's the ultimate self-agency, I feel.
So that's the conclusion we came to. Was actually, wait a second, you're actually accelerating towards the bad scenario if you don't have the information.
Exactly.
But it was funny because like there is this like, maybe you're at peace because you don't know something, but if you're a high agency person, you actually want to know because you can take action.
100%.
You can correct it, right?
100%.
Yeah, it's very interesting. Let's talk about the company itself. You've raised quite a bit of money.
Yeah.
You have this crazy story as to how you started the business. It sounds like you were already doing some genetic kind of like study and understanding in what I'll call the traditional, kind of college world, et cetera. But then at some point you were just like, all right, screw it. I got it from here, guys. You dropped out and like basically did self-study.
Oh, yeah. Well, so my interest in genetics goes way back, as I mentioned. So let's just take a step back. I think understanding this story goes back all the way to the beginning. I'm a first generation American. Both my parents are from Iran. They escaped during the 7-9 revolution, came to America. I like to say that, we have the kind of first generations have the immigrant drive and that hunger with the opportunity of America, right? So it's a beautiful combination. And then I mentioned my cousin who kind of suddenly, passed away in her sleep. And at the time I kept asking my parents, how does this happen? How does this happen? I was 8, I didn't understand. They kept saying, bad genetics, bad genetics. What does that even mean? I didn't know. Eventually I started studying genetics. And what I realized was that disease isn't really necessarily kind of an inherent property of someone, right? Maybe you could actually kind of correct a, mutation or a variant in DNA difference that actually causes a disease. Could you cure a disease? So in high school, I joined a do yourself genome laboratory. It was actually in Brooklyn, kind of second floor of a warehouse, right? Where, in this closet, effectively, we engineered yeast to make them luminate. We edited bacteria to make them resistant to antibiotics. And I love this kind of beauty of biology. And I started thinking about what if you combine this kind of depth and beauty with something that's a little bit more iterable, because one thing about the wet lab is that the life cycles could be so long, right? You make a mistake, it's like, forget about it, it's another week. On the computer, you made a mistake, you just click the delete button. So I went to Penn where I studied computational biology for around a year and a half. And at Penn, I remember I was in Bio 221, which was genetics class. And the chairman of the biology department basically brought up this beautiful chart of the decreasing cost of whole genome sequencing. Okay. And when you look at this chart, you can look it up and look it up. It basically says that whole genome sequencing was around $1 billion in 2000, right? Sequencing a single genome was $1 billion. And then at the time, it became $1,000. So it's an exponential decrease on a logarithmic scale, right? It beats out Moore's law. And I thought to myself, wow, this price is going to go to zero. Then what? What's going to happen, right? So I kind of told this to my friend, and he was like, is this going to be on the midterm? I was like, I don't think he's kind of missing the point there, right? So I was like, you know what? I kind of want to analyze my own whole genome data. Right. This is what I really want to do. And then I became kind of obsessed with it. I couldn't get this out of my mind. And also combine that with, I found college to be very stifling, right? Very limited, kind of this like, it just felt, yeah, I think suffering's a great word. It just felt so limiting. Like I wanted to become free almost, right? I want to express my kind of deeper inner soul, right? I said there's the Joseph Campbell quote, have the inner being match the physical plane. That's what I wanted. So I left, moved back into my bedroom. COVID's going on. So I'm in my bedroom in Brooklyn. And basically this begins a year-long like intellectual journey where I filled in 18 subject notebooks on statistics, on genetics and some programming things to figure out, okay, how do I actually, to answer this question, how do I actually analyze my whole genome data? And the way I like to think about it is like basically during that year, I built myself up to kind of an intellectual frontier. And it's almost similar to being in a plane and looking down. You first see like a sea of green when you look at a forest. But as you get down and down and down, it starts to become more granular and you start seeing basically huge holes in the forest. And then you go, how's no one here? So then you go and you say, wait a second, I'm going to start planting my seeds. And you start planting your seeds, and suddenly you start what I think of as productizing intellectual alpha. Right? You have this intellectual alpha, you have this frontier knowledge, then you start taking that knowledge and basically creating a product. And that's what Nucleus is. And that's why it's the deepest expression of my soul. So in doing that, eventually, my parents, of course, were immigrants. They weren't, too happy. Like, what are you doing in your bedroom all day? Thankfully, we managed to, I texted eventually at some point a year later, I texted cold, an angel investor, Corey Levy from Z Fellows. Highly recommend, by the way, if any early stage founder is getting the journey started, highly recommend Z Fellows. I texted Corey, and then, a couple weeks later, God bless, he gave $100,000. So that was kind of the journey. That was the beginning of it. And
when he gave you the $100,000, it was just you?
Yeah, it was just me.
And what was the plan?
The plan was to build the next Google. No, at that point, what happened was we ended up raising around $300,000 from Corey, Ed, and a bunch of others. And I went and I basically recruited the person who became the CTO as well as the head of operations, COO. And then we started basically creating a mock-up. And then parallel to that, I was also emailing this scientist who became our chief scientific officer. I was asking him kind of very technical questions under actually a pseudonym, funnily enough, because I figured, I'll do all the science. I just need, once you come to the frontier of knowledge, well, who knows, the frontier of knowledge, what other scientists do, right? So I was basically able to speak to other scientists, ask them very technical questions. And then eventually, I think we realized that we had the kind of same vision, right? Because there was one of the first papers I ever read when I was in the bedroom was a paper on this kind of D2C polygenic score site. And so the creator of that, we actually ended up acquiring that software that I read about years ago, around, a year later. And then the creator of that actually ended up coming on as our CSO. So there's a, complex, kind of web of people, but it all started with that first, 300K approximately. And at that point, there's this funny video of me kind of bursting out of my home. We have this little Nest camera, bursting out of this home screaming when the first 100K basically came in, right? When they said, we'll invest, because it was so much pent up fanaticism, love, energy, so.
And today you guys operate in person or remote?
We're predominantly in person. Mm-hmm. I'm trying to move everything to in person. We're predominantly in person.
Yeah. And how do you operate the company? Like, it's unique in that you're trying to build what some would look at as a tech company, some would look at as a science kind of lab and research and kind of non-tech in that way. So how do you operate on a day-to-day basis?
That's a great question. Nucleus is complex because I like to joke that, half of us have a PhD, half of us are under 25. But if you think about Nucleus, there's multiple components. One is like kind of statistical genetics and bioinformatics. And there's like classical software engineering, full stack development, systems architecture. Yet another is like clinical operations, right? Part of clinical operations is like actually building a genetic testing infrastructure, right? Genetic testing infrastructure itself has multiple components, requires multiple different expertise. There's a regulatory component. There's a kind of more classical operations component, just like, operating, like, customer service, et cetera. Then there's design, right? Actual product design, UI, UX. There's communications. Communications is very huge, as I alluded to earlier, right? Our product is communications, right? We give people information. That's communications. And I can go on, but as you can see already, there's such a diversity of skill sets and backgrounds required to operate a company like Nucleus. So it really requires, I think, someone who, and I'm fortunate that, I spent so much time kind of building what I think of as the intellectual castle. So once you build the intellectual castle, what new employees may not fully appreciate, which is okay, because employees should abstract things away, is they're walking around your castle. So I like to say when a new employee is onboarded, there's actually 10,000 assumptions that have gone into what the ask is. Mm-hmm. Right? There's 10,000 things they actually don't know was assumed before I say, hey, go do this thing. I like to say, like, if you're in a castle, I like to go back to the castle analogy. If someone's like fixing a window, right? They're not thinking about the plumbing, not thinking about the lights, not thinking about the floor, they're not thinking about the foundation of the castle, mm-hmm. right? They're not thinking about who comes and cleans the castle every week. They're just focused on their specific task, right? So I think as a founder, you have this kind of intimacy where you understand and appreciate what the person's job is and then how it fits into the broader picture, right? And that requires, I think, quite a unique skill set of being both very investigative, mm-hmm. right, but also enterprising. I think often someone's one or the other. To be both is extremely powerful, especially for building a frontier tech company like Nucleus Genomics.
Mm-hmm. Now, what is like the long-term vision? Now, obviously, you don't want to just do kind of the genetic readings. There's a whole bunch of things you could do. Like, how do you think about the idea maze of where this goes?
I think you have to build a consumer-centric, real-time, quantified health platform. So ideally, eventually the platform goes, hey, Kian, as a 24-year-old in Brooklyn, wow, you had super high LDL levels in your last blood test. Mm-hmm. We found people, wait a second, that's actually not a surprise because we found people with similar, who are in the 90th percentile like you in their genetic disposition for familial hyperglycemia. Of course, you're going to have a high blood pressure high blood cholesterol, so high LDL levels. So then it says, well, maybe if you actually we found people similar to you, if they go on their Peloton 3 times a week for the next 4 weeks, they see a 10% reduction in their LDL levels. And by the way, when you go to Amazon, i.e. Whole Foods, you probably shouldn't buy that white rice and that ribeye steak. In other words, the actual integration of this entirety of this data. And then part of this too is leveraging, AI. People always say AI these days. AI is a tool, right? It's a tool. And that tool, I think, will be most consequential in the application of genomics. If you look at the founder of NVIDIA, Jensen, he actually talks a lot about this a lot. He says it's actually not the B2B software tool. It's actually in genetics and biology more broadly, where AI will be most consequential. And I think part of that is alluding to what I said earlier, which is if you look at any disease or trait, there's sort of this like missing gap between how much the genetics theoretically explain and how much they currently explain. Mm-hmm. I think closing that gap is obviously one of the grand missions of Nucleus, to basically perfectly predict us to the theoretical maximum from a primary DNA sequence.
It's interesting that we need artificial intelligence to understand the machine that has created intelligence, right? Yeah. Like to a degree, you know more about your car than you do your body.
Yes.
And so in order for us to better understand ourselves and the quote unquote, superior intelligent, being, we need artificial intelligence to get there.
Yeah, I think
today's episode is brought to you by CrossFi. CrossFi is the Apple Pay for crypto. For the first time in history, anyone with a Web3 wallet like MetaMask can spend crypto through a physical or virtual Visa card anywhere in the world where Visa is accepted. No more exchanges or middlemen. Just link your wallet, get your card, and start spending today. CrossFi card transactions have already been successfully processed in New York, Los Angeles, London, Dubai, China, Japan, and over 20 other countries. Be one of the first to get your hands on a CrossFi card and a prize pool of up to $3 million by joining and participating in their testnet today. You can go to xfi.foundation/users. Again, that's xfi.foundation/users. Go check it out today.
Genomics, the DNA is a very complicated circuit. And I suspect that what's going to end up happening is there's going to be more of a black box model that hopefully becomes more and more interpretable over time, but initially probably a more black box model that can already start making predictions that go beyond actual kind of causal mechanism explanations, right? And to put that a little bit simpler, it's like I can make a prediction about something without necessarily understanding how it shapes that thing, right? And that can be very true in genetics too, where you have like an association, but you don't necessarily understand how that DNA variant actually shapes the disease or trait in question, but you do understand it's associated. And I think that's something really fundamental to think about in statistics and with AI, which is that you can have prediction without explanation.
Now, as you think through, again, understanding and now this evolution to action, there are don't eat this, you should eat this, kind of external inputs to their impact on genetics. What about just changing the genetics themselves, right? So obviously CRISPR, we've seen a lot of talk around steroids or peptides or, many of these things, and some of them don't actually impact directly the genetics or kind of DNA sequencing. But there are quite a bit of conversations right now about, do we have the technology and will it be ethically kind of approved to actually begin to edit what our genetics, kind of are initially?
Yeah. Before you can edit anything, you have to actually understand like causality. You have to understand like mechanism. So we're still ways off from understanding sort of the complex architecture of some of these diseases and traits, right? As I said, it's a complex interaction of many different DNA differences in someone's genome. So that's the first step, is actually understanding more and more, which is to say, how did these different DNA variants actually shape someone's trait? Then the second part of that is to, theoretically at least, do kind of, if you were actually going to employ genetic engineering, I think genetic engineering is a very powerful technology. Very powerful technology. I don't think it's discussed enough. I think we need a lot more conversations as a society to think about, hey, this technology is coming. this technology is improving. How can we appropriately integrate into society, right? It's not something it's kind of similar to the information thing. I think we believe that, oppressing technology, hiding information, it just splinters society, right? Mm-hmm. I think sunlight is the best disinfectant, and we should bring technology and empower and educate people so they understand its implications. And to that point, if you were going to actually employ some of this technology due to the nature of the architecture of some of these diseases and traits, you'd have to do something called like multiplex engineering, which is basically you have to engineer multiple sites in the genome, which is actually very difficult already. It's hard. People are trying to have no off-target effects, where that means basically if I intend to change, DNA letter, I actually change a different one. That's obviously really bad. And then there's another implication, which is that, genetics and nature, it's all a balance. And what I mean by that is that, if you can optimize, say if you could actually engineer for something like intelligence, right? Someone might say that. What you find is that, in these different intelligence variants are actually associated with different potentially neuropsychiatric diseases, or even, like autism, right? So I think we have to be very deliberate and understand that there's not like a kind of panacea solution here for genetic engineering. Nature is all about balance. And there's something fundamental to that I think as humanity is going to start appreciating more and more as we come across these questions of genetics and society.
Now, if you guys are successful, how does the world look differently in the future?
I think a couple things. Every time a baby's born, their DNA is sequenced. And basically, ideally, you kind of track the entirety of all their different molecular data in real time the second the baby's born, right? So I always think that the vision for a company like Nucleus is to basically, there's two kind of main parts. One is on the kind of, inheritance part. One is kind of human health part. So let's start on the human health part. I think you have to basically look for all possible molecular signals prior to there's any obvious phenotypic signal to flag before the onset of disease. Mm-hmm. In other words, what I'm saying is that diseases, there's always actually some, and you can see this with a lot of the different people in the kind of quantified health. If you really start quantifying your health, you find that there's always some molecular anomalies prior to, you get a cough, prior to, you start feeling not good, or prior to there's some like obvious phenotypic like signal that something's wrong. If you can actually flag those molecularly, that is the ultimate disease prevention, right? I actually think there's very small examples of this already. Let me give you an example. 8 Sleep. Mateo's, friend of both of ours. If you look at 8 Sleep, I have an 8 Sleep. One time I went to sleep on the mattress and, I woke up the next day and said, your heart rate was up 50%. Heart rate's up 50%. That must be a bug, must be a mistake. I feel perfectly fine, right? I do the kind of, check. Everyone does this kind of mushy qualitative check when you wake up. Oh, I feel fine, whatever. And then around 24 hours later, I think this was a while ago. Was it COVID? Whatever. It was some sickness. I had some sickness and I was like, basically knocked out. And I remember thinking to myself, that's interesting. Actually, in a way, the 8 Sleep kind of flagged it even before I knew.
Yep.
And then if you take that to the extreme, imagine tracking, and also talking about AI, if you're tracking all these different molecular signals at one time in real time as a consumer health platform, that's probably the most powerful health technology that could ever exist, right? It's actually the ultimate integration of all this data on a single layer. And there's probably going to be an AI that actually sits on top and tracks everything you eat, everything you do, every time you work out, right? Constantly adjusting and updating its estimates of your risk for conditions, right? It's almost like this like super health, I don't know, like this health omniscience that like sits inside of you that tracks everything, right? That's on the human health side. On the inheritance side, I think a couple of things. One is I think, people still don't understand, as I mentioned earlier, that the power of carrier screening. Every person who gets sequenced, because once you get sequenced, and this is one of the reasons, is you can identify if someone's a carrier for a condition. If mom and dad are both carriers, then obviously there's a lot of implication for the offspring. You have to be very judicious and careful because you don't want your son or daughter necessarily to be born with the disease. So given that, I think one of the first things that's going to happen is you'll basically see the elimination of sort of kind of monogenic diseases. I think monogenic diseases, like if parents both want, they have the liberty to say, actually, wait, I don't necessarily want my son or daughter to be born with this disease. And it's literally just a Punnett square. Like everyone learned this in 8th grade, right? It's multiplication. So that's another thing. And I also think there's going to be eventually, probably very, very much long-term, but the kind of integrated genetic stack from, sequencing, analyzing to what you alluded to earlier, editing, where I think genetic engineering technology can be very powerful. We have to be very judicious. Obviously, as I said, nature's balance, right? Nature's this delicate balance. You have to be careful. But I do think that the kind of genetic stack is going to get built, right? From the kind of theoretical to the practical. And I think that's going to, obviously be, literally, it's literally going to change society and who we are. I think we have to be careful. Again, I want to really stress that, which is that we need to start having these conversations today. It's not for me, it's not for Nucleus to make these decisions on behalf of society. We're a part of society, right? We understand, as being the kind of leading genomic startup, there's a lot of responsibility. And we want to be very much bring in constituents and parties now, before the technology is honestly fully baked, and start talking today about the implications. Because they shouldn't just be something that's like, you bring out, 30 years from now, hey, by the way, we can do this, right? It's not the job for the academics or the scientists just to have and kind of, cover up. It's our job to give this information and this power to the people.
Now, there's going to be a lot of people who watch this, listen to this, and they're like, these two guys are full of shit. What are they talking about? There's no way that we're going to be able to scientifically do this, or it is dangerous to go do this. What do you think the real risks are, if any? And how do you think about mitigating risk as you build the business?
Well, I definitely think there's a lot of risks. As I mentioned, one is we don't currently understand the architecture for a lot of these conditions. So there's a lot of unintended consequences or unknown unknowns, right? Even if someone wanted to do multiplex engineering, the technology is not there. You might end up, engineering, different parts of the DNA unintended. People might get disease, they might die, right? That's obviously not what we want. It might be the case that if you actually do optimize for something like intelligence, what might end up happening is you optimize for a disease, right? So there's a lot of unintended consequences. I also think there's always that question of humanity taking control over their kind of own genome, right? In some way, you can make the argument that different innovative technologies, us been always taking more agency over our bodies, but there's something very primary about DNA that we have to be, I think, very thoughtful about. And I really want to stress that, like, in this podcast, this conversation, it's an opportunity for people to start engaging. I don't see these things being spoken enough about, right? I think like things go through their hype cycles, right? Genetics has never had its hype cycle, which is good for us, right? It's alpha for us, right? But on the other hand, I do think it's important people start really thinking seriously in the same way they actually think about like general artificial intelligence, thinking seriously about genetic engineering, thinking seriously about this kind of genetic stack and saying, how are we as a society going to start kind of integrating in this technology, right? That's really important. And it's not being spoken about enough, I think.
When you say that there hasn't been a hype cycle yet, and that's a positive thing.
That's a good thing. That's a great thing.
Do you anticipate that there will be a hype cycle in the future, or actually the ideal condition is that the industry avoids all hype cycles and kind of continues to grind upwards?
I don't really know. It doesn't really matter to me. We're going to win. It can be a hype cycle, it can be not a hype cycle. I don't know. I feel like
Well, hype cycles, they bring capital, they bring talent, they bring attention,
noise.
Right? They bring noise as well. And so there's positives and negatives to it. Obviously, AI, crypto, right? We've seen some of these over the last couple of years. And so I think some companies say, look, when the hype cycle comes, I take the positives and try to avoid the negatives. Other people get smacked by the negatives, and, right? They completely, business blows up or whatever. And so it's an interesting way to think through, like if you haven't had a hype cycle in your sector, whether you actually want one or not.
We're just building, right? Like some of these things I think about, if anything, I think about in the context of like, it's almost a good distraction. There's other hype cycles, right? Like I think people are building like commodities, wrappers over, LLMs, let them do that. Like we're building what I think will be one of the most consequential companies ever, right? Let us keep doing that. Money, the hype cycle can come, it can not come. I've been doing this, figure out hype. I've been doing this, hour 11, sick in my bedroom, 11 p.m., on notebook page, 249. Talk about lack of hype cycle. In other words, what I'm saying is like, there's a level of kind of focus that we have that can come, it can not come. We're locked in. So yeah.
Where do you think that comes from? Like, why are you so focused?
I think it comes from both a love and fear. I think there's definitely a love. To me, like the intersection of kind of science and product and alchemy of creating something from nothing. It's so beautiful. It's the most beautiful thing I said. It's an expression of my soul. I love that. Also comes, I think, a little bit from fear, and that definitely, I'm a first generation American, as I said, right? There's definitely an expectation, right? I think I said this in Alex's podcast too, which is like when you're in your bedroom, it's there's many people you don't want to disappoint, right? Your parents came here, they made a lot of sacrifices, right? You don't go to, you know, a school like Penn and then leave it, you know, because I'm gonna, you know, follow my dreams. What does that even mean? You don't do that, right? It's like against the culture. You don't do that. Similarly, you don't want to disappoint yourself, right? Because there's always, of course, there's always doubt, especially in the bedroom. There's doubt. Can I do this? Can one person do this, right? And that doubt is fear, but I do think there's both in that push and that pull. There's that love and that fear, right? There's that fear, like I don't want to, you know, like I'm scared for you know, out of my mind, but also that you know, pushes you, that's motivating to you. But then also there's the love of what you're doing. So the combination of both is intense, unwavering focus. So
how does that feed into who you recruit to come work at the company?
I mean, people need to be. I think people need to be absolutely focused. I mean, there's no doubt about that. I think we have a very diverse, eclectic mix of people at Nucleus. I think that's something that's like underappreciated too. People from all across the political spectrum, people with a variety of different kind of ideologies, etc. And I think part of that is actually beautiful, because I almost wanted to kind of in a way emulate society, right? I almost want, you know, there's that kind of Steve Jobs analogy with the rocks hitting each other. The rocks hitting each other, and then all of a sudden they both come out polished. I really believe in that fundamentally. And that's why I think these conversations are so important, because we can talk publicly about these things. Some people might love it, some people might hate it, but they're definitely talking about it. And that's very important to me, which is bringing this and giving this information, this knowledge to people. I think internally, people need to have that intense focus, but I don't necessarily expect people to agree with me either. But I think that will make us all better. That will make the product better. That would make us even more judicious and thoughtful while still accelerating.
And then my last question is around like regulation, or maybe I'll just call it the rules. And the rules are both, we've talked a little bit about maybe kind of like society's perspective on like what's inbounds and what's out of bounds, even if it isn't necessarily backed by science, right? It's just kind of like the public thinks something. What are the regulatory kind of considerations for something like this? I'm assuming that there are multiple regulatory bodies that you all interact with on a daily basis. What are they trying to accomplish? Do you feel like those rules are good, bad, they need to be improved? Like just talk about that kind of apparatus. Yeah,
well, Nucleus is we follow all regulations, and we always follow regulations. It's definitely an evolving space in terms of regulations. And we're excited to work with all the regulatory bodies to, you know, continue to make sure we're kind of fully compliant. I definitely think that people have the right to their whole genome data. People have the right to know basically what's going on inside their body. And I think part of Nucleus's mission, and part of, I think, the government's mission, is to make sure that we can give people life-saving insights, right? If a piece of information can save someone's life with a single swab can read your entire genome finally, and you know what one piece of communication can save your life, that to me sounds like something that everyone should have access to in a manner that's, you know, sure, regulated, that's also, I think, HIPAA compliant. You know, we're also CLIA and CAP accredited as well, so there's a way of doing that kind of responsibly, but still making sure that people have access. That's really important to me. And I think Nucleus embodiment, that's true today, so I'm happy about that.
Is there anything that surprised you so far in building the company?
Oh my God. Everything. This is the classic answer. I can give you a non-classic answer, but the classic answer is it's so hard. I mean, everyone says it. It's so hard. It's like, what does it actually mean? It's just like, I think there's a Paul Graham quote where he says, you know, one thing about when you leave college, if you leave college and you start a company and it works, or it starts working, you know, it's like you start running as fast and as hard as a human being can run at age like 20, 22. And I think reading that when you're 15, you're like, wow, I don't even know what that means. That sounds kind of fun. But then you live it. And basically the idea is you see it becomes like all consuming. It's just all consuming. It just takes over everything you have, every being, every part, like every spirit, soul, whatever, everything goes into the company. And I think that kind of process is beautiful. It also definitely takes a certain kind of personality. Entrepreneurship is not for everyone. It is not for everyone. It is, you gotta be willing to, you know, quote unquote, die on the court, I think.
What is the percentage confidence you would put right now on the company succeeding?
I mean, you know, it's funny because it's almost like always a trick question. Sometimes VCs ask me this. And I'm like, but they don't understand. Like, either company succeeds or like I die. It's like if I throw my head into the wall to make it succeed, it's gonna succeed. It's almost like I read this thing recently. I think Dorkish posted this. It was basically said like, if you do everything, you will win. If you do everything, like everything. And I think they used Lyndon Johnson as an example. Lyndon Johnson was, a complicated person, but in terms of like persistence and just doing absolutely everything. Sometimes I think to myself, oh, it's interesting. Like Lyndon Johnson's interesting because, if you read Caro's biography, there's this like level of intensity and like insanity and like pathological likeness to his work. But he literally did everything. He literally did everything like a human being could do. And then he became president. Mm-hmm. So you have to wonder like who becomes president? Well, maybe the person that does everything, right? In the same way, like if you went to him and said, what's your confidence he's going to succeed? He'd probably be like 100%. And again, I think you have to learn from these stories and that he did a lot of things that he honestly shouldn't have done that was a little bit ethically fraught, right? So I think doing everything is not an excuse for that. I do think though that there is something to this idea that's like, if you do everything that you can in your capacity, if you give something your all, it has to be inevitability. You bend nature to your will. So let's just say 99%.
All right. We'll keep track and we'll do this again.
Bob.
We'll do this again in the future.
Okay. That's great. Thank you so much for having me.